College Algebra 2, Lesson 4, Graph Approximations to Factored Polynomials. Here we have an equation. We could say y is equal to f of x is equal to 1 over 42 times x minus 2 times x plus 3 times x minus 7. We're to draw an approximation. We'll focus on step 1, determine the leading term. So if you were to actually multiply x minus 2 times x plus 3 times x minus 7, you would see we would have x cubed minus 6x squared minus 13x plus 42, and all of this stuff is times 1 over 42. I do not want you to do this. We could think of it this way. You have three terms with x in it. X times x times x is x cubed, and you have the 42 in the front, 1 over 42, so it's x cubed over 42. So we don't actually multiply the stuff out. But if you did, the leading term is the term with the highest exponent of x. That determines the shape of the function. So now, what does the shape look like? Well, let's go start on the lower left, and I have a big S there, and it's going to finish upper right. Now, why is that? Well, if you were to put a number in for x cubed, say negative 10, it'd be negative 10 cubed. That's minus 1,000 over 42. That's negative. That's below. And then if you were to put in 10, it'd be 10 cubed, 1,000 over 42. That's a big positive number. If you put in minus 1,000 and 1,000, then you have the extremes. You're way down below and you're way up to the right. And something's going to happen on the x-axis. We can have at most 3 points where we touch the x-axis. They're called X-Intercepts. They're relatively simple. All of these problems, we have factored polynomials. So we can just look at it and say, well, if you put in 2, for x, you'd have 2 minus 2 times 2 plus 3 times 2 minus 7. The only important thing is 2 minus 2 is 0, so you get 0. And you do the same for the others. But this is, we're just focusing on the leading term. It's x cubed, and the shape is going to be not a very math word. It's snake, but you call it a cubic. But if we had x to the 5th over 42, it would also look the same as the cubic in a lot of respects. It'd be like a snake. We could have x to the 7th, x to the 9th, x to the 11th, and so forth. They all have the same sort of shape, and we're trying to draw an approximation, not an exact graph. Now we're going to plot the zeros of the function. Those are the numbers that make f of x 0. So certainly if you let x equal 2, f of 2 is 0, so we have a big red dot at 2. If you let x equal negative 3, you would have 0. There's a big dot at negative 3. And if you let x equal 7, you would also have a 0 for the function. And just to be sure, we count over blocks. We got 1, 2 is 2, 3, 4, 5, 6, 7. And what we'll have to now do is to draw a line through all of these points, and we got to be sure that we hit the y-axis at the correct point. We will now plot the y-intercept. How do we do that? X equals 0. Where does the curve touch the y-axis? So f of 0 is 1 over 42 times 0 minus 2 times 0 plus 3 times 0 minus 7. Most people don't even bother with that. They just say, well, if it's 0, we don't have to write it. And they would have it's over 42, and they just think of a 0 for x. So it's negative 2 times 3 times negative 7. Two negatives, you multiply them together, you get a positive. And 2 times 3 is 6 times 7 is 42. Over 42 is 1, and we see a big old blue dot. And the y-axis, that's the y-intercept. Now the challenge is to start on the lower left, go through each of the points that are given, and see what it looks like. And we're also going to do, we're going to put an O or an E according to the power where the numbers come from that is the zeros. Now, x minus 2 is to the first power. That is an odd integer, so we could put an O under the red dot for x equal 2. We will also do an O for odd under the negative 3, and the same for 7. They have an odd multiplicity. If it's odd multiplicity, you must go through the x-axis. Now we see the green curve is the graph. It's an approximation. We started on the lower left. We go through the x-axis at negative 3. We go through the y-intercept at 1. We go through the red dot at 2. We go down, we cross through the x-axis, and then we go across through the x-axis at 7. And we have the O for odd, and that's why we went through the x-axis at 3 points. Here we have our second example. F of x is 1 over 32 times x minus 2 to the first power, but then write the 1, x plus 2 to the fourth, x minus 1 to the fourth, and x plus 1 to the first. Now, what makes x minus 2 0? 2. So we see a red dot on the right-hand side, and there's an O under it because the exponent is 1. What makes x plus 2 0? Negative 2. So we see on the left-hand side a red dot, and there's an E under it because the power that it comes from, the negative 2 plus 2, 0, is 4, which is even. And when it's even, we can only touch the x-axis at those dots. We also have x minus 1 to the fourth. 1 makes it 0. So we have a 1 at the red dot on the right-hand side, and we have an E under it because that's to the fourth power. That's even. And our last term, what makes x plus 1 0? Negative 1. So we see at negative 1 we have a red dot, and we have an O under it because that's an odd power, and those are our zeros of our function. Now, how do we get the leading term? Well, if you were to multiply x times x to the fourth times x to the fourth times x, that would be x to the 10th. You would add the exponent, so it's x to the 10th over 32. The shape will be a cup. Now, it's also true if you had x squared, x to the fourth, x to the 6th, 8, 10, 12, 14, 16, 18, even numbers, you get a cup. It has wiggles at the bottom, but you will start on the upper left and you will finish on the upper right, and you wiggle around, so to speak. Now, what's the y-intercept? If we plug in 0, so it's 1 over 32 times negative 2 to the first. You don't really have to write to the 1. And then we have 2 to the fourth, negative 1 to the fourth, and 1 to the first. Now, negative 1 to the fourth is 1. You don't need to write it. 1 to the first, you don't need to write it. So what we're left with is negative 2 times 2 to the fourth. 2 to the fourth is 2 times 2 times 2 times 2 is 16. Negative 2 times 16 is negative 32 over 32, which is a negative 1. And we see we have a blue dot at negative 1 on the y-intercept. So if we start upper left, we come down to the first E, we touch it, curl it up, go through the O, grab the y-intercept, head up to the next E, touch it, curve around, then go through the O, and then we have our cup. For our third and last drawing, we have f of x is 2 times x minus 1 to the 10th times x plus 1 to the 11th times x squared plus 7 to the 4th. And if we count exponents, x is to the first power. Then we got 10, and then we have 11, and it's x squared to the 4th, that's x to the 8th. And we count up all those exponents, we're going to have x to the 30th, and it's a 2 in front of it, so it's 2 times x to the 30th. 30 is even. The shape is a cup. Start upper left, finish upper right. Now, if we look at the x-axis, I have a red dot at -1. That's the x plus 1 to the 11th power. That's odd. 11 is odd. And we have a red dot at 1. X minus 1 to the 10th. You put 1 in there, you get 0. That's to the 10th power. It's even. X is to the first power. What makes x 0? 0. So that's odd. It's to the first power. We only have 3 dots on the x-axis. What happened to x squared plus 7 to the 4th? Well, the problem is there are no real numbers that you can plug in to x to get x squared plus 7 to be 0. If we gave it some thought, it'd be like plus or minus the square root of 7 times I. You can't plot I on the y-axis or the x-axis. So there are no real numbers that make x squared plus 7 0. But we still have to count the leading term. It's x squared to the 4th. That's x to the 8th. So we start upper left. We come down to the -1. We go through the dot. It's odd. We curve around. We go through the origin. That's odd. Now we have an even. We go touch it and then go back up, and that's our cup. This concludes the video on how to graph polynomials that are already factored. So it's kind of like a textbook problem. In real life, you rarely would have forms, polynomials to high degrees that they're already factored for you. That's probably the hardest part of polynomials, is to factor them. So, but these are factored polynomials, and how do you graph them?